Do you want to experiment with circuits and learn about electronics without the expense and risks of real life components? Luckily, we have many options for this thanks to software based circuit simulators. Some of them run offline, some are web based. And there's probably at least one for your platform, be it mobile device, desktop, laptop, Windows, Mac, or Linux. There's something for everybody. In this video, we'll be looking at a couple of different simulators. Some have more of a focus on analog electronics, while others are purely digital logic simulators. So let's get right into it. All right, so the first question to answer is exactly what is a circuit simulator? Well, it's any software tool that lets you design and test electronic circuits without the use of a real life component. However, not all simulators are the same. They all have their pros and cons, from relatively simple models that teach components and principles to advanced ones that use SPICE directives, which are used by engineering students and professionals. Many simulators simply use ideal circuit models with a few tweakable options, but some allow for more specific models and specific advanced models, which allow you to simulate a real life component more closely. There are a number of simulators I also won't be covering because of like the costs, such as Proteus. The license for that is can be hundreds of dollars, thousands of dollars for an institution, so I won't be covering that. And some of them you have to do too much to install them, so I won't be covering them, although I'm always open to new tools to be recommended that I can cover. I also won't be going over fritzing, which it does support SPICE directives for simulation for parts, but I've only found a handful of parts that actually support all that, and most of the parts made for it are basically just for a cosmetic layout tool. All right, since I've mentioned SPICE, I should really go over it. Now, SPICE, which is short for Simulation Program with Integrated Circuit Emphasis, it first came out in 1973. It was first programmed in Fortran, and it was a game changer because it became the first widely adapted software-based solution for circuit prototyping and experimentation. Previous to this, engineers generally had to simulate circuit with pencil on paper and actually had to make the calculations by hand on how the circuit should work. You could also prototype circuits with real life components, and there was even some prototyping done on analog computers, but this was a very expensive proposition and it was out of the reach of a lot of engineers. SPICE itself has actually gone through several versions. It eventually switched to C, and Spice 3 was last released in 1993. However, there were a number of successors that were first built in the 90s and then going into the 2000s to Spice, with LT Spice being probably one of the most widely used ones, although its interface is a little bit like Windows 95, but I think there are other even more recent Spice simulators. While not part of the Spice family formally, there are a number of circuit simulators that do accept Spice directives, either for their advanced model or an actual Spice-based simulation. I will have to give a bit of warning that Spice simulators are very complex and aren't beginner friendly at all. I'm actually just starting to learn Spice myself. Um, but if you're looking to be the best at circuit prototyping with software-based solutions, learning how to use Spice is probably your end goal. Now, the first program we're going to look at is LT Spice, which is basically the end goal of anybody wanting to learn to design and simulate circuits. But as you can tell, the interface is very, very dated. I'm talking Windows 95, 98. There's no way to really make adjustments in terms of the size of things. But let's just get into it. Well, let's start with a voltage source. That's pretty easy. Keep in mind, it's really hard to see these lines. But we've got our minus, we've got our plus there. Well, let's put in a ground. Actually, is that even the right thing? I can't even tell. Whoops. Let's see. Okay, a wire connecting the two. Yeah, I can just barely see it. Um, well, let's see. Do a resistor, and this will be a diode. I have to rotate it around because it'll be an LED. Let's see. A new diode, I guess. Go through the list. Let's find LED. I guess any LED will matter. Say red, whatever. Because with Spice, yeah, you can define the specific components, not just the general. So let's put a wire in between connecting everything. Oops. Keep in mind, this isn't pretty like every circuit or anything. So we're not going to see any animations. We're probably not going to see a light up either. Let's see. Let's run simulation. I could do transient, but the thing is, it never changes. It's just 5 volts. Actually, wait a minute. Let me change the resistance. I don't know. Let's say 1,000. What kind of simulation could we actually really do here? I mean, we can say start time 0. Not really familiar. Let's see. Time to start to, I don't know, 1, 1. Sure. Okay, well, okay, no, stop time. Okay, what's stop? Oh, no, stop time, not start time. Okay, no, 10 seconds. And unknown parameter. Okay, let's try this again. I don't know, DC sweep. Say name of this first source to sweep, I guess. Linear. Start a value at, well, 0. Stop at 5. Go by 1. Let's see what happens. Take very it's missing parameters. As I said, I'm learning this myself. So let's see, DC sweep. Say B1 here. Started at 0, I guess. Bring it up to 10. Permit it by 1. Still not working. Say V. Yeah, no, see, I'm still kind of lost with how this is. So this definitely isn't for the beginners. Now I'm going to begin with every circuit, and that's actually where I began with understanding electronics and circuits. It's an easy to use circuit simulator that runs in a web browser. And more importantly, it's designed around touchscreen on mobile devices. So this is something you can easily use on your smartphone. It doesn't need to be downloaded and basically works in just about every modern web browser that I'm familiar with, but obviously it also needs an internet connection since there isn't an offline version. Components themselves are pretty easy to place, with wires simply being connection between nodes. You simply click on one node, click on another, and then it puts a wire. That's the upside of not having to place the wires, but the downside of not having any real control on how they are routed. I highly recommend this for entry-level education, again, based on my own personal experience, keeping in mind that it's dealing with ideal circuits and components and isn't really good for simulating more complex circuits. You should also be wary of using it as a blueprint for real-life circuits, but again, it's not a bad place to start. It has some nice animations illustrating current flow, LEDs, etc. It also has waveform generators that can act as multimeters or oscilloscopes for your simulated circuits. The values can be adjusted in real time and they can either be typed in or there's even dials that allow you to simply use your finger on a touch screen, which can make it a lot easier there. There's only one simulated real life integrated circuit chip, and that's the 5.5 timer chip. There are some generic IICs such as counters and display drivers and whatnot, which can, if you understand those, you can transfer that knowledge to actual real life ones. Customization of the components is fairly limited, but that makes it great for beginners. You really don't have to know all the dozen or so important physical properties to the item, but this can be really annoying for more advanced students. This might be something you'll probably eventually graduate from, but this is a great place to start. I do frequently use this for circuit demonstrations as the circuits are really easy to see and understand. Now, here's something almost any beginner can use, although you do learn a lot. It's $15 USD for the full version, and you can do, I think, some stuff, look at circuits for free. You don't have a whole lot of components, but if you're a beginner, this works. You've got your voltage sources right up here, so let's grab a voltage source. We've already got a ground. It usually comes with a ground automatically. Um, this voltage source is set at 5 volts. You have both the dial on the right that you can set things, and you can also type them in. And it does give you waveforms, flat, sine wave, pulse right there. We'll get into that later. So let's set our value to 5 volts. We'll attach the ground. Now that ground is automatically attached to the wire. There are no separate wires with every circuit. It's just connecting the nodes, which can be annoying sometimes because you can't control the routing of the wires. All right, well, let's bring up a. Oh, yeah, I got this thing set to change the settings here, wherever the settings are. There we go, right over here, settings. I'm going to change it back to ANSI American version. So let's grab us a resistor. I want to say 1K, but this may not work because the way the simulation is. Um, and let's just pick an LED. We haven't gotten to diodes or LEDs or anything yet, but just keep my word here that this is how it's supposed to attach. So we've got waveform, so we can set colors. Um, the lowest would be red, and the highest would be violet, indigo, something. Just pick something. Let's pick something in the middle, like green. Then voltages and current. It's just this isn't a very ideal LED. 2 volts, 20 milliamps. So, all right, well, keep in mind, we hit true. We don't say anything. Why? Because we haven't connected the whole thing to ground. Even though this is connected to ground back here, because it's a two terminal, this is still not connected. So we click on this node, we click back here, and now we've got a complete circuit pathway. So you can see the power actually flowing the current. Um, but apparently in this case the milliamps is so low it's actually not going to light up. Now in real life an LED would probably light up at least a little bit and actually be very readable with a 1K resistor. So if you do this in real life, yeah, the LED will light up almost certainly. So let's tune down the amps. Let's bring it down to, I don't know, bring it down to 470. So it's glowing. Now again, at 470 it would be a lot brighter than this, but we've got 6.63 milliamp We've got 1.88 volts. So we see our resistance, we see our power. This is a DC source. So yeah, it's pretty easy to get started with every circuit. The next one I'm going to mention is Fallstead Circuit Simulator, which is sometimes shortened to Fallstead or just called Circuit.js. It was originally created by Dr. Paul Fallstead as a Java applet meant to run in a web browser. He technically still owns it, but it's been modernized, which I think began somewhere between 2010 and 2012, so that it now runs on JavaScript and it runs easily on modern browsers. It has both an online version and a downloadable offline version, and since it's just JavaScript, I think it can be adapted for just about every modern platform. It's completely free. Every version uses the GNU GPL license so that any modifications or variants have to remain open source and free, although I haven't found any variants, at least not yet. It can be a bit tougher to learn than every circuit since the interface and the animations aren't as pretty, but it has a better simulation, far greater number of parts, and even options for using SPICE data to create specific models. It is still very actively maintained with new features coming out. Somewhat recently, they introduced subcircuits, so you can basically make your own parts. Um, it's still closer to something like every circuit compared to LT Spice, and there's a lot of things it can't simulate, like microcontrollers, dev boards, or microprocessors, although it does have a far greater range for ICCs. I do also use this a lot in my videos, so many of my circuits will probably be shown in every circuit, again, when possible, and Fallstead, again, also when possible. Now we've got Volstead Circuit Simulator, sometimes called Circuit.js, because it is an updated version of Circuit Simulator. With JavaScript, I think they first started doing that in, I don't know, 2012, whatever. This may be a little harder to see some of the stuff, but you can get used to it. Wires are their own components here, so let's start with a ground. In this case, you actually draw it, so you have to know which direction to draw. There's our ground. Let's find Now there's a lot more components with Circuit Simulator here than it is with every circuit, so you have to kind of look around. There's our voltage source. Question is, what do we have it the right way? Easiest way to do is you can now edit and you can do the circle symbol. And no, it's actually reversed, but we can just click on it, swap terminals, and we're good. 5 volts, same signal, simple that's used on every circuit, but that's not the official one. The official one is this for power source right here. So next, let's grab ourselves a resistor. Well, right here, resistor. Put that in. Again, we actually got it set to the PN resistor. There we go, 1K. Let's look for outputs, LED. The LED here. And of course, now this is running by default. If we want to pause it, we click on this and it'd be red. We can also reset. So, but we need wires now. So there's a wire there. Now we got to get a node or else it doesn't correct. You'll see it's floating and the color is red and it's lit up. Um, we can see we can add 3.322 milliamps, but it's lit up unlike every circuit. Like this should be very visible in real life. If you were to do this, how much volts is going through? 1.678. Um, our powers, it's in a little over 5.5 milliwatts. You can actually get more information. So let's look at, you can actually put in scopes and stuff. Let's do that. I'm going to introduce that in every circuit later. So we'll visit that in a new scope. So right here, okay, it's outputting 5 volts, um, and the current is 3.322, which is basically determined by the value of the resistor here. So let's put the light into a scope. Both cases, it's gonna indicate the voltage and the current. So we need to make some adjustments. So let's just turn off the voltage, the current part. Um, do the same here. Let's see. There we go. So we're outputting 5 volts, but because of the resistor, it's getting reduced to 1.678. And again, put our line over. Now it's DC because this is not going to be anything interesting, but yeah, you can look at the actual numbers. So let's just remove the scopes. And that's how it works in Falstad. Next we have Circuit Lab. This one is also web browser based, and it has both free and fairly cheap pay models. The free model, I think, appears to be limited to the number of components in your circuit, but there may be other restrictions. There aren't any animations, although the LEDs still light up, and the simulation is a lot closer to SPICE, but with some simplification. This can be a great way to actually learn about SPICE analysis and how simulations in SPICE run. Now let's take a look at Circuit Lab, which is also web-based, and I don't have the paid version, so we'll just see what we can do here. This also has some simulation like SPICE, so it can kind of introduce you to SPICE directives. So let's start with a DC power source. Okay, good so far. Okay, let's get a resistor. Actually, I think I have to do. Okay, there we go. We should be all connected. Set the resistor to 1,000. Okay, let's find us a LED. See, I don't know this photodiode. Yeah, okay. Um, oh, whoops. I don't remember how to rotate here. Let's see. Okay, it's actually all right. For our LED, it's whatever it is, and you can actually pick some specific models. Um, Again, I have no idea model names or anything, but this should be fine for now. All right, we click on. We go connect it automatically. Um, Need a ground. The ground. Whoops. Actually draw our path here. All right, now simulate, but what kind of simulation do we actually want in terms of numbers? Um, Again, this is a lot simpler in LT-SPICE, but it gives you an idea. So we could do DC sweep. Could pick this. Um, let's just say what happens at 0 volts. We'll end it at 10, and we'll do a step of 1. Okay. Select one output. I am thinking here. Um, I don't know. D1 dot volts. I guess. Let's see what happens. Oh, we did. Hold on. Whoops. Okay, let me try that again. Had this. I don't know. This will be volts of that, and this will be amps. But let's see what happens. Okay, gives us a curve. So as the voltage goes up, we can see that it uses more current. Um, yeah, and then this is volts too when we start at 0. So let's see what happens at 1. Of course, we're at 2, obviously. And then, oh yeah, okay, so here's 0 volts, 0 volts. Okay. At 1 volt, we're getting 977.1 millivolts to the LED. 2 becomes 1.427, and 3, and then 4. And then when we get to 5, which is kind of where we've been running it, 1. 6, 8, 7. So basically the numbers that we've seen on every circuit fall stat and whatnot. I might go back to LT Spice and actually try that again. I'm still learning myself. So, but that's really all the information. We're not seeing any pretty animations or anything, but that's how it works with Spice. It just gives you numbers and graphs. You don't see pretty blinking lights, just like with this. So this is Circuit Lab. Next, we have something called Tinkercad, which is a little bit different from the last couple of ones I talked about. This focuses more on simulating the Arduino Uno Rev 3 and the microbit coding for both, but it does have a lot of other parts and it has a basic analog simulation. So there's some stuff you can do there. It's put out by Autodesk, and it's basically a way to advertise some of their other products. If you like designing circuits with this, Autodesk has that kind of thing. But yeah, it's actually a good place to start. If your entry into the world of electronics has been buying a Arduino Uno Rev 3 compatible development kit or the BBC Microbit, which is the official one. I don't know, I'm sure there's is actually pretty cheap. It's a little bit more child friendly, but anyways, so yeah, and it supports code for both those development boards. It is limited in parts compared to some of the others, but if that's the direction you're going, this could be a good start. All right, here's Tinkercad, which is something basically completely different, and this is definitely meant for beginners. It's a way for Autodesk to kind of show off some of the things they can do in the hopes you buy more of their products. So they've got a little basic 3D designer, they've got one for making circuits, they got code blocks and whatnot. Um, so let's make a new circuit. Let's see what we got working with here. Now the parts are very limited. This is kind of for selling what they can show in Arduino and BBC Micro kits. Um, but let's see what we can do without that. Let's see. Oh, here's a breadboard. This is something we didn't have in the others. We're going to need a power source of some description here. Let's see, what do we have? Starter. Let's see. There's some power source somewhere here. Um, let's see what happens when we bring up battery. All right, yeah, it gives us a few basic sources here. Let's pick the 9 volt. Let's rotate it around. Put the positive to this one. We'll put the negative there. Actually, you know what? We'll put the negative down here. Make it easy. Now let's color our wires. Oh no, wait. Whoops, got that mixed up. All right, so as we discussed in a previous video, we're wiring 9 volts directly. How can we verify that? Let's see. I know there's a multimeter. Okay, this basic, simple multimeter thing. All right. Oh, oops. Okay, let's put a wire there. Let's put a wire all the way up here. Let's see what it says. Actually, it doesn't say anything because we haven't started the simulation. But yeah, there we go. We got 9 volts if we were to hook a real life multimeter. Now keep in mind, even though you see the trappings of a 9 volt, this is still a ideal circuit simulator. All right, let's see. Let's do resistor. Find one. There we go. No, that's something built. Okay, here's a resistor. Um, so we're gonna put it right smack there. We're gonna say it's 1 kilo ohms. Okay, good default. All right, let's pick out an LED. So we probably don't have a whole lot of options, but there you go. Um, let's see if we can flip this. There we go. All right, so we've got our LED. I'll put it down here. This row is connected internally. So we've got our power, our resistor. Now we just need say a wire to go to ground here. And I think it's set black, yeah. All right, let's see what happens. It lights up. Okay. Um, could this be too much voltage and enough? I think we're good here. I'd have to run the numbers on 9 volts and 1,000, but yeah. See, light lights up. There we go. Start it, stop it. That's all this is, just a very basic circuit. Next, we have Walkwe, which has some similarities to Tinkercad. The one thing is it doesn't really simulate analog circuits, but it has a lot of support for a good number of microcontroller-based development boards. It can simulate several Arduino models as well as ESP32, Raspberry Pico, and even some STM32 models. As I mentioned, it does lack true analog circuitry support because that's not really what it's designed for. So things like registers are purely cosmetic, although there are some ways to fake it. But you do have pulse width modulation support. All of that's going to be mentioned in future videos. There are limitations with each of the dev boards that are being simulated. For example, SPI and I2C can only function in master or controller mode, and you can't use the analog comparator. And there's other limitations with other boards. You can also only simulate a single dev board at a time, so there's no way to have simulations of multiple boards talking between each other, which again was something I wish they could fix. The parts are kind of limited, but sometimes they can be faked with a thing called custom chips, but you have to have some advanced C programming knowledge to use them. There is Wi-Fi support, no Bluetooth support, but sometimes the private gateway that's only available for paid members is necessary for many of the applications. There is a free model, but be warned if you're trying to compile and run at peak times, even a small program can take a long time, which can be both challenging and frustrating. All right, we're going to check out something a little bit different now. This is Walkme. Now, this isn't a circuit simulator in the sense that it really can't simulate analog stuff. So resistors are going to be pretty much cosmetic, although you can light up LEDs. And this is a great tool if you're starting out heavy electronics with a development board already in mind, because it supports a lot of different things. Um, see, like it'll do just for Arduino, it'll do classic Uno Rev 3, it'll do a Mega, it'll do a Nano, Tiny 85, a Fresino, which is a whole thing to explain. Working on the assumption that you have an Arduino Uno Rev 3 or something compatible, just click on that and you get an Uno and you get the place to actually put in your code. Let's see, what could we do? We can do closest thing I can think of is grab a resistor. Again, this is actually kind of cosmetic. Whoops, nope, I didn't want to do that. All right, take the resistor, we'll attach it to pin 13. We will take a LED, attach it there, and then we will, see, yeah, wire here to ground. Um, Now this is not going to do anything because we don't got code, but let's see, in mode 13 output, and then just do it once. We'll write I 13. I'll be explaining this in a video here. Let's see, what am I missing? All right, I realized what I did wrong. But anyways, yeah, I've got resistor connected with wires. I'm not bothering with the breadboard. It's going to ground, and we're having pin 13. Oh, congratulations, we've got an LED. However, this doesn't have capacitors or diodes and LEDs, but it doesn't do all the analog simulation. This is really about code simulator, so it's kind of barely a circuit simulator, depending on your definition. Next, I discovered something fairly new recently, and that's SimuIDE. Simuid, I don't know how you say it, but it's free and it's cross-platform, and it simulates both analog and digital. It has a really large library of microchips and even a couple of microcontrollers, actually. It seems to be a nice medium if you want something more advanced and varied than every circuit or Falstad. Um, and I think it'll even handle multiple microcontrollers, dev boards. I haven't really tried that out. So that breaks through some of the limitations with Walkme and Tinkercad. It's completely on offline, so it'll have to be downloaded. I saw versions for Windows 64 and 32-bit, both x86 processors, Linux 64-bit, again, x86 processor, and Mac OS, again, x86. I didn't see any ARM versions, so you're not gonna be able to run this on Raspberry Pi or your smartphone or whatever. All right, here's another program I just discovered while I was making this video, Simu IDE. It's actually pretty neat. It's got a lot of stuff in it. So let's just make ourselves the basic circuit we've been doing. We need a voltage source. Oh, let's see. Instead of voltage source, we'll go with battery. Scroll. Oh, whoops, wrong thing. Let's try this again. There we go. Battery. Um, as you remember from Falstad, there was a special symbol for DC source. This is the special symbol for battery specifically. All right, so we're going to make this a little bit different. Let's see. Let's go with a resistor. I guess it only does the European version. Let's change properties. Let's make this 1,000 ohms. Let's connect wire here. Um, Yeah, we're going to need a ground wire here. Let's look for an LED. There we go. Here's an LED. All right, let's connect it up and see what happens. All right, let's simulate. There we go. It's lit up. It's not pretty, but it's doing the job. Um, we could grab a probe. Oh, oops. Grab a probe, and we can just probe at certain points. Let's see. So we know there's 5 volts flowing through here. After the resistor, it becomes 2.4 volts. That's interesting. Maybe it's the nature of the battery. I'm not really sure. Uh, Still 2.2. And once it gets past the LED, yeah, we're at the bottom of the hill. We could also bring out, let's see, let's bring out a voltmeter. Trying to remember how this works with this. Let's see. Maybe with 3 terminals. Whoops, come on. Oh, oh, because I'm set to a wire. Whoops. Let's see, try to remember how this works again. All right, see that. I think this is the probe point. Let's see. Okay, 5 volts. Oh, it's okay. It's going around. This would blow up the light actually if this was true. Um, Again, for the life of me here, let's see. Let's do that. Okay, no, that just changes that. I can't remember off the top of my head, but yeah, it's the same circuit as we've done before. There we go. It lights up. Um, so and lastly, we have CircuitVerse. This is a web-based teaching tool. It does have a paid version, I think, to remove ads. The thing is, it's focused around teaching digital logic and designing digital logic circuits. It's not a general purpose simulator, so it's not working with analog circuits or any of that. However, you'll probably get to a point where you'll want to learn about digital logic, and we're obviously going to cover this in future videos. It even gets into some of the ideas behind things like CPU design. Now, let's look at circuit first. This is something a little bit different. It's really about digital circuits. I'm not even sure. Well, there are variable LED. There's an LED. There's a digital LED. All right. Let's see, an input. So we're really dealing with digital logic here, so it's not analog. There's a ground. Let's see. I think I can really only do a simple input. Let's see. There we go. All right, let's see how this works. Oh, I just realized. Problem is, I don't think there's a resistor. All right. So I'm not really sure how this works. So circuit force verse, if it works at all. Constant value. Okay, and a value of 5. No, that's not gonna work because it's digital logic. It's supposed to be lighting up or whatever. It's timing group. Okay. Well, that's circuit verse. We'll probably look at it more again when we get into digital logic. So just to wrap things up, let's recap. Circuit simulators are a software-based solution to allow people to educate themselves, develop, and experiment with circuits without the inherent problems and dangers and expenses of real-world components. SPICE was first developed in 1973, and it became a popular method for simulating circuits. As I said, it was a real game changer. And even though it ended development in 1993, there's been a whole host of SPICE-based simulators such as LT Spice. But keep in mind that using these is probably way too advanced for novice users, and a lot of these tools are actually meant for engineering students and professionals. I also went over a number of simulators such as Every Circuit, Falstad, Tinkercad, Circuit Lab, etc. Each of them, of course, has their own purposes, pros, cons. I highly recommend checking out all the ones that I've mentioned and try to figure them out as you continue to try to learn about electronics.